Hello students, today I have the question number 31 to 38 for Neet 2018 paper series of code AA. So I will take the 8 questions. First I am taking the 31st question. To 38. 31 question. 31st. 3 objects A is solid sphere, A solid sphere, B is circular disc, thin circular disc, C is circular ring, each have the mass m, each have the mass m and radius r. They all spin with same angular speed. They all spin with same angular speed, omega, about their own. Symmetry axis. The amount of work done W required to bring them to rest. Would satisfy the relation. Would satisfy the relation. Now first is WB greater than WA greater than WC, and second WA greater than WB greater than WC, and third is WC greater than WB greater than WA, and the fourth option is WA greater than WC greater than WB. This is the relation. We have three objects: solid sphere, thin circular disc, a circular ring, and they are rotating about their own axis of symmetry with the same angular speed omega, and they have the same mass and same radius. So we know that when the object is rotating about their own axis, it has the rotational kinetic energy. So rotational kinetic energy. Rotational kinetic energy W, this is equal to half I omega square. This we know. I the moment of inertia, omega the angular speed. And the moment of inertia of all these objects are different. So first we take for solid. For solid WA equal to 1 by 2, and for solid I is equal to 2 by 5 mr square into omega square. Now 2 and 2 will cancel. 1 by 5 come below 0.2 mr square omega square. Now then we take the circular disc for circular disc WB equal to half, and for disc the moment of inertia about their own axis is 1 by 2 mr square into omega square. This is 1 by 4, so 1 by 4 means this is your 0.25 mr square omega square. And then circular ring WC is equal to 1 by 2, and for ring this is your mr square omega square. So this is your 0.5 mr square omega square. Now you can see that for circular ring the work done is maximum, then this is less for circular disc and minimum for solid sphere. So we have the relation this WC greater than WB and greater than WB. WC greater than WB greater than WA. This is in the descending order. Descending order, this is maximum, then minimum, then more, less, then this is less, then this is the least. So thus we get this relationship, and our right answer is third. This is the third answer. So you just apply the formula of rotational kinetic energy and then put the value of moment of inertia and then find the relationship between WA, WB and WC. Now question number 32. A moving block having mass m moving block having mass m collides with another stationary block of block having mass having mass 4m the latter block comes to rest. The latter block comes at rest. After collision. After collision. When the initial velocity of light initial velocity of lighter block is V, the value of coefficient of restitution, the value of coefficient of restitution E will be. Now this is your option are 0.8, third is 0.25, second 0.25, third is 0.5, and fourth is 0.4. So now the solution. What is given in the question? The mass of the latter block is m. So we have this m1 equal to m. Another mass block 4m. So this m2 equal to 4m, which is stationary. This is given stationary. Stationary means that the u2, this is equal to 0. The latter block comes at rest after collision. This after collision, now this u1 is given to be now v. This is given the latter block, and this v1 is equal to 0. But the speed of v2 is speed of heavier mass is not given. So this we have to find. So coefficient of restitution. Coefficient of restitution E equal to minus delta V upon delta U. So this is what? E equal to minus B2 minus B1 upon U2 minus U1. This is the formula. So everything is given, but V2 is not given. So you have to find the V2. So first we find the V2 is equal to 2 M1 U1 minus M1 minus M2 into U2 upon M1 plus M2. This is the formula for the velocity of the second block. So this is your 2, this is now your M, U1 is equal to V, this is now U1 V. Then this U2 is equal to 0, so this is now 0 upon M plus 4M. So this is equal to 2mv upon 5m. M and M cancel. So this gives you that this V2 is equal to 2 by 5 V. This is the value. Now we will put all these values in this formula. E equal to so much. Therefore, E equal to, now this V2 is equal to 2 by 5 minus, this is now your 2 by 5 V2, V1 equal to 0, this is your minus 0 upon U2 minus E1, U2 is equal to 0, U2, and U1 is equal to V. So this is 0 minus V. So this is what? Minus will cancel, so we will have this 2 by 5 V upon V. So this will cancel. So from here E equal to 2 by 5, or this is equal to 0.4. So the value of coefficient of restitution is 0.4. This is now right answer, 0.4. So our answer is fourth. So what we have, you just apply the formula and find out the quantities that are given in this question, and then find the unknown quantity and then put the value and calculate the value of coefficient of restitution. This is the dimensionless, so it has no unit at all. Now question number 33. Which of the following statement is incorrect? Which of the following statement is incorrect? First is, frictional force opposes the relative motion. Frictional force opposes the relative motion. Second statement is, limiting value of static friction limiting value of static friction is directly proportional to normal reaction. And now third is, rolling friction is smaller. Rolling friction is smaller than sliding friction. Sliding friction. Coefficient of sliding friction. Coefficient of sliding friction as dimensions of length. As dimensions of length. So these are all given here. This is the laws of friction. First is opposes the relative motion. This is also correct. Static friction is directly proportional to normal friction. This is also correct. Rolling friction is smaller than the sliding friction. This is also correct. the coefficient of sliding friction has the dimensions of length. This is wrong. Because no coefficient of friction has the dimensions. All the coefficients are dimensionless. So our right answer is fourth. No coefficient of friction have dimensions. So our right answer is the fourth one. This is the theoretical question and direct depending upon the laws of friction. Now question number 34. A toy car with charge Q with charge Q moving on a frictionless plane surface. Plane surface. Under the influence of uniform electric field. Uniform electric field. Due to the force QE, due to the force QE, its velocity increases from 0 to 6 meter per second. 6 meter per second in 1 second. In 1 second. At this instant, the direction of direction of electric field is reversed. The car continues to move. The car continues to move. For to next, for to, or to more seconds under the influence of this field, the average velocity and average speed, the average velocity and average speed of the toy car, between 0 to 3 seconds. Between 0 to 3 seconds are respectively first is 1 meter per second and 3.5 meter per second. Second is 1 meter per second and 3 meter per second. And third, this is your 2 meter per second and 4 meter per second. And now fourth, this is 1.5 meter per second and 3 meter per second. 3 meter per second. Now the solution. Now we are given a toy car. This is the frictionless surface. This is a toy car. This is toy car. It has the charge Q. An electric field is applied on it in this direction. This is now electric field. It moves for 1 second. This is given in the question that it moves for 1 second and it gains the velocity from 0 to 6 meter per second. This means that the initial velocity here, this is not 0. Initial velocity is 0. After 1 second, the car is here. And this now speed is 6 meter per second. This is at 1 second. This time is taken to be now 1 second. This is now 1 second. This is 1 second. Now then it moves. Now at this time the electric field is reversed. The electric field is being applied towards the right side. But now electric field is reversed so that it becomes on the left side. It means that the electric field is now like this. And in this electric field it moves for more 2 seconds. So what happens? That the toy car is now here. This is move again for, this is suppose the time from this one is 1 second, and then for next, this is like this one, and this is also for 1 second. So now we have to see that what will be the average speed and average velocity. So now from here, this is now position A, this is now position B, this is now position C, this is now position D. And when this is in this way, then this car moves opposite to this one in this direction because of this electric field. So what happens? That in first, we will find the acceleration. So using the first equation, v equal to u plus at. Now v is given to be 6, u is equal to 0, and this a and t is equal to how much? This is now 1. So now its acceleration will come out to be 6 meter per second square. So this it means that this is being accelerated for 1 second with the acceleration of 6 meter per second square. So what will be the distance moved by this one? So distance, this is suppose distance is now x1. This is x1. This is suppose now x2. And this is now suppose x3. These are the distances. So x1. So s equal to ut plus half at square. So this is how much? S is this is your x1. This is now u is equal to 0 plus half, a is equal to 6, t is equal to 1. So this will cancel. So it's now 3. It means that this x1 equal to 3 meter per 3 meter. 3 meter. Now we have to find that what would happen when the direction of the electric field is reversed. Definitely it will be retarded. Since this is moving with this acceleration, so this will be the same retardation. So this will be the retardation. So what will be the velocity at this point C? So velocity at C. This is again equal to now this. Suppose this is now your V equal to, again you apply V plus U plus at, and U is here at this time. This is now given now 6 meter per second, given in the question. Given in the question. For 1 second it has the speed 0 to 6, that it means that the speed here, this is now 6.1. So this you apply now 6. This is now being retarded because of this electric field. So A will be now your 6 and T is equal to 1. So this gives you that V equal to 0. It means what? That this toy car will stop at this point C. It means the toy car will stop at C. So what will be the distance? X2 is how much? So this is X2. Again we will apply this formula S equal to ut plus half at square. So this is what? X2 equal to, U is given to be now 6, T is equal to 1 minus half, A is given to you now is 6 and T is given to be now 1. This is not so much square. This will be now 3. So this is your x2 is equal to, this is now 6 minus 3, so this is equal to 3 meter per second. This is now 3 meter. So here the x1 is coming out to be 3, this is also coming out to be now 3 seconds in 1, but now this will be in this reverse direction. In this reverse direction because of this electric field E. So what will be the distance? When this stop at this point, then it will start with the speed 0, so that it moves for a distance x3 for 1 second. For 1 second. So again, what we have? We have to find the distance to this one. Motion from C to D. Now V is equal to U is equal to 0. Retardation, that will be your again it will have the speed your V U plus 80. So now speed after this will come at so moving with rest. This is now 0 plus A. This is being the minus sign because of this reverse electric field. So this is now your 6 into T. So if velocity is equal to how much? T is equal to 1 second. So this is your minus 6 meter per second. So much speed it will gain. Now again the distance will be how much? Distance. Now x3 equal to ut plus half at square. Again apply the formula. U is equal to 0 plus, now this is your 1 by 2, A is minus. So this is now your 6 and T is equal to 1. This will be your 3. So from here we get x3 equal to minus 3 meter. Minus sign is indicating that this toy car is moving in the opposite direction. So now we find the average velocity. First we find the average velocity. Average velocity. Your x1 is equal to 3. x1 plus x2 plus x3 upon 3. So this is x1 is equal to 3, x2 is equal to your, this is also 3, and this is now your minus 3 upon, this is now your 3. Total time is 3 seconds. So this 3 and 3 will cancel. So this will come out to be 1 meter per second square. 1 meter per second. And now average speed. Average speed, so we will take now 3 plus 3 plus 3. We will not take the minus sign because we will take the magnitude only. This is the length. This is now upon 3. So this is your 9 upon 3, so this is your 3 meter per second. So average velocity will be 1 meter per second and average speed will be 3 meter per second. So now we have this 1 meter per second and 3 meter per second. We have the right option is second. This question is somewhat difficult, but we have to understand that after the application of the electric field, for the first time the car moves only for 1 second. For that you find out the acceleration and then find out its this distance. This is not easy to find here. This x1. Now then after this A to B, then we go to B to C. Then B to C, we have to find this again. What will be the velocity for next 1 second? So next 1 second the velocity coming is 0. It means that this toy car will come at rest at the point C. So how much is the distance x2? x2 is how much? Now car is moving. So x2 equal to ut minus plus half a t square. U is given to be here the 6 meter per second. So this is now your 6 and minus you will take because we have the electric field reversed. So the car will be retarded. Then we take the minus sign. So this will come out to be 3 meter. And then from C to D, this has come at rest, but because of this field, this will again move to some distance. Let we have taken the distance x3, but it will move towards the left side. So what we have this v equal to, now again we have the velocity equal to 6 meter per second. Minus sign indicates that this is in the reverse direction. So this is the final velocity after 1 second. After 1 second. Now again x3 equal to ut plus half a t square. Now since here the toy car was at rest, so we have taken u equal to 0 plus half a t square a minus 6, and this is now your 1 meter per second. So again we are getting 3, and then find the average velocity and average speed. And remember, then when we find the average velocity, we have to take into account the sign of the displacement, positive or negative. But when we are finding the average speed, then you have to neglect the minus sign and just you add all the distances and divide by the total time. That will give you the average speed. So according to this one, our right option is second. So our answer is second. There is one more method to calculate to this one, that you can draw the graph between V and T. Alternative method. Alternative method is that just you do it. This is 0, this is 1, this is 2, this is 3, this is your 6. So here we take the velocity and here we take the time, and then up to this the velocity increases. So we are getting this line, and then this retards, and at 2 seconds, 1 plus 1, 2 seconds. This comes as rest. This is now this, like this. Now then, because of this electric field, it moves again with a speed of 6 meter per second. This is now minus 6. So this will take the minus 6. Then this graph will go like this one. So this is for next 1 more second. This is minus 6. So this is O, A, B, and this is now your C. This is point C. So now what you do, just you find the area, this area, and this area. These two areas will come out to be positive, this area will come out to be negative. So area will give you the distance. This distance will come out to be now 3. This distance will also come out to be 3. This distance will also come out to be 3. But this is now minus 3. So again you can have. This is x1. This so much is x1. This is x2. This is x1. This is x2. This is your x3. Just we find this x1 is equal to 1 by 2 into 6 into 1. So this is now 3 meter per second. 3 meter. And x2, this you again find 1 into 6 into 1. So this is now your 3 meter. And then find x3 minus 1 by 2 into 6 into 1. 1. So this is equal to minus 3 meter. This is what I have calculated here. Then again find the average velocity and average speed. You will find the same answer. So you can do in either way. Either calculate it or have the graph, velocity time graph. This is your question number 34. Now I am taking the question number 35. Thirty-five is given a block of mass m. A block of mass m is placed on the smooth smooth inclined wedge ABC of the inclination theta of inclination theta as shown in the figure, as shown in the figure. The wedge is given a acceleration. The wedge is given an acceleration A towards right, the relation between A and theta. The relation between A and theta for the block to remain stationary, on the base is first I am drawing the figure. This is given here. This is angle theta. Here is a block. This is given the acceleration A. This is A, B, C. A, B and C. This is given here. And now options are: first, A equal to G cos theta. Second is A equal to G upon sin theta. G upon sin theta. And third is A equal to G upon cosec theta. And now fourth option is A equal to G tan theta. These four options are given here. Now the solution. So for its solution, we are given this this is the block, and acceleration is given in this direction. When this is taken in this direction, the acceleration is given towards the right, the block will move towards the upside on this direction up to A. This is now A, B and C. This angle is theta. So now what we have, there are the two forces because of this block. One is the weight mg. Second is the reactional force R, normal reaction. Always remember that the normal reaction always acts in the direction perpendicular to the base AB. So whatever we line draw, this one that must make an angle of 90 degree with this AB. Now if you draw to this one, then you will find that this angle will come out to be theta. By little geometry we can have this, the component of this R is equal to this, R cos theta, and another component to this is now so much R sin theta. So what will happen? Now we are having these forces, the force due to the reaction, force due to the weight and force due to the acceleration. So this acceleration must be balanced by some force. It means that this force must be equal to this force due to the acceleration A. So what we have, these two components, these components R cos theta and mg, both are equal and opposite. So for equilibrium, of block, what we have, this R sin theta, this is equal to ma, mass of the block, and R cos theta equal to mg. Right? So now just you divide, you will get this R sin theta upon R cos theta equal to ma upon mg. mm will cancel, R will cancel. So now tan theta. Tan theta equal to A upon G, or you can have A equal to G tan theta. So this is the right option coming out to be the fourth one. So our answer is fourth. So remember for this one that this we divide this r into the two components, r cos theta and r sin theta, and then we for the equilibrium we apply the equations. And if suppose this a would have not been there, then we have not to resolve this r, but better to resolve this ng. So this is our right answer to this question 35. And now question number 36. The moment of force F equal to 4I plus 5J minus 6K at two 0 minus 3 about the point 2 minus 2 minus 2 is given by. Now your option is, first option is your minus 7I minus 8J minus 4K, and second is 4I minus 4I minus J and minus 8K, and third option is 8I minus 4J and minus 7K, and fourth option is minus 7I minus 4J and minus 8K. This is the question. What this is given the point, here the force is acting F. Now this force is given, the point is given to be now, this is now G2, 0 and minus 3. About the point, this is now another point. This is what? 2 minus 2 minus 2. This force is being applied, so this is being rotated in this way. This rotates in this direction. So what we have to find? We have to first find this value R. This value R. This is now your R. So R will be how much? Now this is suppose the point this is O, this is now suppose P. So now it's this R1 for this with respect to origin, R1 equal to, this is equal to 2I minus 2J minus 2K, and R2 with respect to origin to this one, this is equal to your 2I minus 0 and minus 3K. So this is equal to 2I minus 3K. This is so much. Now this R will be how much? Therefore, this R is equal to R2 minus R1. R2, this is given to be 2I minus 3K. This is so much minus R1, this is now your 2i minus 2j and minus 2k. So what we have? 2i minus 3k minus 2i plus 2j and plus 2k. So 2i and 2i will cancel. This is equal to, we are having this j, 2j and minus 3k plus 2k, so this is now minus k. This is now R. Now you find the torque. So torque, movement of force or the torque, this is equal to R cross F. So torque equal to, R is given to you this much, 2j and this is now your minus k cross. F is given to you here. This is your 4i plus 5j minus 6k. This so much. Now you can solve it by the method of determination. Determinant. This is your I, this is j, this is k. Now first I is equal to 0, this is now 2, this is now minus 1. 2 minus coefficients of j and k and I. This is now your 4, this is your 5, this is your minus 6. And now you find this is equal to I with brackets minus j with brackets plus k with brackets. So I, for I, just we add into this one, the I. So this is 5 to 6 minus 12. And this is now your minus sign and this is now minus 5. So this is now your plus 5. J, minus j we will add to this one. Then this will be your minus, this is now 0, minus 6 into 0. Then this is now your minus 4, so this is now your plus 4. And k we add to this one, then this will be your 0 and this is minus 8. So what we have? This is equal to minus 7i and this is now minus 4j and minus 8k. This is the torque. So our option is fourth one. Minus 7i plus 4 minus 4j minus 8k. Our option is 4. So now right answer. Now question number 37. So to understand this question is that you are given the points, and for these points first you find the position vectors R1 and R2, then this R equal to R2 minus R1, and then find the torque R cross F. Either you multiply each of these elements with the other one, or you find by the method of determinant. Ijk is plus, minus and plus. For this you multiply like this and this one, and for this you multiply this two and this to this, and for k you multiply this to this and this to this with proper sign. Now 37 is a student measured. Measured the diameter the diameter of a small steel ball, of a small steel ball using a screw gauge, of least count 0.001 centimeter. The scale reading is the main scale, reading is 5 mm, and the zero of circular scale, circular scale division coincide. With 25 division, about the reference level, If screw gauge has zero error, if screw gauge has zero error of minus 0.004 centimeter, the correct diameter of ball the correct diameter of ball is. Now your options. First option is 0.053 centimeter. Second is 0.525 centimeter. Third is 0.521 centimeter. And fourth is 0.529 centimeter. Now this is the question from the screw gauge, which is taught in the 11th class. Now bundle calipers, screw gauge and spirometer are the three instruments which are taught in 11th class. So what the questions related with all these instruments may be asked in the Neet exam. So remember that you have not to leave them without study. Now what we have, the diameter. This is main scale reading plus circular scale reading minus error with sign. This is the formula. Main scale reading is given to you how much? This diameter we denote it by this, suppose D. This is your 5 millimeter. Your answer is given in centimeter. So this is now 0.5 centimeter. Circular scale reading, the given division is 25. So just you multiply this by the least count. This is given to you now so much, minus this is given to you minus 0.004, so much. Okay, so this is now 0.5, this is now you 0.025, and this is now plus 0.004. कितना हो जाएगा ये? 0.529 centimeter. This is the correct option. So our answer is what? We are having this fourth. Answer is fourth. So the zero error is subtracted with the sign. If suppose this would have the positive, then this will be subtracted, because this positive and negative will be negative. And when this is given negative, then negative and negative positive. So this will be the answer. Now the last question, 38. A solid sphere is rotating. A solid sphere is rotating freely about its symmetry axis. Symmetry axis in free space. In free space. The radius of the sphere is increased. The radius of sphere is increased, keeping its mass constant. Its mass constant. Which of the following quantity? Which of the following quantity would remain constant? Would remain constant for sphere or sphere. Now the options are: first is rotational kinetic energy, rotational kinetic energy. Second is moment of inertia. third angular velocity, and fourth is angular momentum. Angular momentum. Now rotational energy, this has the formula half I omega square. So when R is increased, I will increase, it means the kinetic energy will increase. Kinetic energy, rotational kinetic energy. Rotational kinetic energy. Half I omega square. So increasing R, this rotational kinetic energy will increase. I equal to 2 by 5 mr square. Now you can see that here R is increased, I will increase, means rotational kinetic energy will increase. So this is no more constant. It is not constant. And now we see the moment of inertia 2 by 5 mr square. If R is increased, the moment of inertia will increase. Angular velocity omega equal to 2 pi upon 2 pi n. And here you will note that the frequency is not being increased, or the time period is not being changed. So there is no change in omega. So this is constant. Angular momentum J equal to R cross P, and P that is equal to mv. This is now R cross m into v. Now we know that this v is equal to r omega. So when this r is increased, then r is increased, then v will increase. So this j will increase. So it is also not constant. So not constant. What is left? Omega. So our answer is which one? This is now third answer. The angular velocity. So in this way we see that the angular velocity does not depend upon the size of the object. Whether we increase the size or decrease the size, there is no change in the angular velocity. But the angular speed, this linear velocity, that changes because it depends upon the r, the distance of the particle from the axis of rotation. Like this, this omega will remain the constant. So omega changes whenever there is a change in frequency or change in time period. Otherwise, no change in angular momentum, this angular velocity. So thank you very much to all of you.